Good morning YouTube and welcome to our channel where we discuss topics related to chemistry and analytical techniques. Today we're going to talk about a fascinating analytical technique called mass spectrometry. What is mass spectrometry? Mass spectrometry is a powerful analytical technique used to identify the chemical composition of a sample. It involves ionizing the sample molecules and then separating them based on their mass-to-charge ratio. The resulting spectrum shows the relative abundance of each ion, allowing us to identify the chemical composition of the sample. How does mass spectrometry work? The process of mass spectrometry involves four main steps. Step 1. Ionization. The sample is ionized using different methods such as electron impact ionization, electrospray ionization, or matrix-assisted laser desorption/ionization, MALDI. This creates charged particles, ions, from the neutral molecules in the sample. Step 2. Acceleration. The ions are then accelerated to a high velocity using an electric field. This separates them based on their mass-to-charge ratio. Step 3. Separation. The separated ions are then passed through a mass analyzer, which sorts them based on their mass-to-charge ratio. The most common types of mass analyzers are time of flight, TOF, quadrupole, and magnetic sector. Step 4. Detection. The final step involves detecting the ions and measuring their abundance. The data is then used to generate a mass spectrum, which shows the relative abundance of each ion and allows us to identify the chemical composition of the sample. Types of mass spectrometry. There are different types of mass spectrometry, which differ in their ionization method and mass analyzer. Some of the most common types include electron impact ionization, EI, in which the sample is bombarded with high-energy electrons to create ions. Electrospray ionization, ESI, in which the sample is sprayed into a high-voltage electric field to create ions. Matrix-assisted laser desorption/ionization, MALDI, in which the sample is mixed with a matrix material and irradiated with a laser to create ions. Time of flight, TOF. Mass spectrometry, in which ions are separated based on their time of flight in an electric field. Quadrupole mass spectrometry, in which ions are separated based on their mass-to-charge ratio using 4 parallel rods. Magnetic sector mass spectrometry, in which ions are separated based on their mass-to-charge ratio using a magnetic field. Interpreting mass spectra. Interpreting mass spectra involves analyzing the peaks in the spectrum and identifying the ions that correspond to them. The peaks in a mass spectrum correspond to different isotopes of the same element, different elements, or different molecular fragments. The intensity of each peak indicates the relative abundance of the corresponding ion. By analyzing the mass spectrum, we can identify the chemical formula of the sample, the molecular weight of the compounds present, and their structural characteristics. Advantages of mass spectrometry. Mass spectrometry has several advantages over other analytical techniques, including high sensitivity and specificity. Mass spectrometry can detect and identify trace amounts of compounds with high accuracy and precision. Versatility. Mass spectrometry can be used to analyze a wide range of compounds, from small molecules to large biomolecules. Quantitative analysis. Mass spectrometry can be used to measure the amount of each compound present in a sample. Structural analysis. Mass spectrometry can provide information on the chemical structure and composition of compounds, allowing us to determine their functional groups and bonding patterns. Limitations of mass spectrometry. Despite its many advantages, mass spectrometry has some limitations. For example, it requires a high level of technical expertise and can be expensive to operate. It also requires a clean and pure sample, and some compounds may not ionize well or may produce complex spectra that are difficult to interpret. However, these limitations can often be overcome with careful sample preparation and optimized experimental conditions. Applications of mass spectrometry. Mass spectrometry is used in many fields such as Pharmaceutical industry, for drug discovery and development. Environmental analysis, for monitoring pollutants in air and water. Forensic analysis, for identifying drugs, explosives, and other compounds in crime scenes. Food industry, for analyzing food quality and safety. Proteomics, for studying the structure and function of proteins. Conclusion: mass spectrometry is a versatile analytical technique with wide-ranging applications. Its ability to identify and quantify the chemical composition of a sample has revolutionized many fields of science and technology. We hope you found this video informative, and don't forget to subscribe to our channel for more interesting topics. Thank you for watching.